So, you want to be the world's best pixel artist, but don't know enough about color theory? Is your line art looking good, but then your actual coloring looks incoherent and lacking that je ne sais quoi? I'm here to make that je ne sais quoi into the sweet science of color theory. Color theory is important in any art that uses color, and the lines between art and science is often blurred. There are usually methods for getting started with color, and this can be finalized to make things look good. The visual appeal is king. So let's jump into the infinite sea that is learning color theory. Also, just to note, in my previous video I spoke about isometric art slightly wrong. Please see the video by Soul Tunes for the right version of ISO art. Link will be in the description. So first of all, color values. HSL is hue, saturation, lightness, and RGB is red, blue, and green. HSL works like this. You have the color wheel, and the rotation of the color is the hue value. So as you can see, this box here, as I go up in degrees, it goes a full 360, and that will be 255 points in hue. Saturation is basically how vibrant a color is. So here you can see it goes to gray, and it goes to very pure red. Lightness is how much white light is in the color. So you have black and you have white and everything in between. RGB is a little bit more self-explanatory. It's how much red, green, and blue you have. Excuse me, adding all three colors makes white, and having none of the colors makes black. And you have it in between. And if you have equal parts, you make a gray. 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 Yeah, so remember that we are dealing with light, not paint. So all the colors combined give white, not black. It's helpful to switch between these two when creating pixel art. Sometimes you need your work to be more saturated, more brighter, and things like that, or complemented. But yeah, so like opposite in the color wheel. Sometimes you just need things to be neutralized. You need things to be hue shifted red, things like that. So what is the difference between additive color and subtractive color? Additive color is dealing with light. So with pixel art, you have light on the actual screen, so you have additive color. Subtractive color is usually what you do what you deal with paint. So most color theory was written before light was in pixels and screens and things like that. So when you're learning color theory, it's most helpful to understand subtractive color theory. And the reason why why light is called additive theory is because you're actually adding red light to the pixels, to the light. You're adding green to the light, and so on. But with pigments, the reflective surface absorbs all the colors apart from the ones that it reflects. So when you have a red paint, it's absorbing all the light apart from red, which it reflects. And so when you add red and blue, it absorbs all the colors apart from red, as well as all the colors apart from blue, and it reflects the color which just so happens to be purple. So you're kind of taking away the light that it can reflect. They're quite similar, but they have their differences. Yeah, so the complement of blue, so if you see here, the complement of blue, the negation of blue here is yellow, but the complement of blue with paint is orange, right? And yellow plus blue makes green in paint, but yellow plus blue, if I just add blue, it just makes white in light. So it's a bit difficult to get your head around, but I'm sure you'll understand. Monochromatic color. This is just one hue, any one hue, but the saturation and lightness is changed. So as soon as you change this, the palette won't be monochromatic. So for example, let me start with a color, any old color. Yep, that's a fine color. Now, say I wanted a color to make a monochromatic palette. I say I want this to be actually darker. This will be my dark tone, this will be my bright tone, maybe a little bit less saturated, maybe this a bit more saturated. And then in graphics too, I can just do spread, and this will give me a monochromatic palette. So this is monochrome. If I start to add, so if I add any sort of hue, if I make it more red or whatever, that's no longer monochromatic. And this is quite helpful when you start filling in your line art with shading, but you're not ready to add color just yet. So you start with line art, which is basically just 2 colors, and then you can add a variety of colors for the filling in, adding how light works and things like that, just a almost black and white gray palette, and then you can start adding colors. So what is a neutral color? A neutral color, this palette is, I would say, quite neutral, especially the darker colors. What neutral color is basically a shade of gray. That's what I consider a perfect neutral color. And for example, its hue should be irrelevant. Saturation and lightness is the only thing that changes. In fact, the saturation stays 0. It doesn't change rather. And these are all your neutral kind of tones. This is what I would consider neutral, especially here. And in pixel art, you might not always use a perfectly neutral color. It might just look a bit too plain and not vibrant. So you might add a little bit of purple, things like that, a little bit of saturation. Let me see what is purple. And a little bit of lightness, something like that maybe. That could be like your starting neutral tone. And yeah, and so you can make a monochromatic palette. Here of your sort of neutral tones, and then from here you can do something called neutralizing a color. Any color can be neutralized. This means that it can have a value of red, green, or blue added to it. So in order to make that color neutral. So strictly speaking, say for example, I have bright red and I wanted to neutralize this. This can technically be its neutralizer, because here I've added nothing but red. So to complement it, I added red and green. This is nothing but red, so in order to negate it, I added green and blue, I'm supposed to say. Obviously that doesn't look super nice, so let's make it less pure of a red, sort of orange. And what I like to do is, this is quite a nice neutralizer, I guess, but the negation function also switches the lightness along this kind of line, so that would be slightly fits in more, it's more harmonious. So that's kind of your neutralizer. This is obviously considering gray as my neutral color, but if I wanted to consider this as my neutral color, I'll just look at its RGB values. Look at this as RGB values, and so this is actually quite bright. So let me see. This is this in lightness. So I'd want to get some color in between these two. So I'll pick this one. So I'll compare. This is this bright, this is this bright, this is this bright. This has about 20 points less green than, but equal red and blue. So I want to add about maybe 60 green, 140 blue, and no red. 60 green, 140 blue, and no red. Yeah. So this kind of gives them more color that's kind of closer to this and kind of more closer to this palette. So it's not a true neutral in the sense that neutral being gray. However, this is my gray in the palette. This is my relative gray in the palette. So remember that all the colors are relative. It doesn't matter if you have one really quote unquote good color. It's how they work as a piece. Right. So what are analogous colors? Analogous colors are colors that are within 90 degrees of each other in the color wheel. So when you create a ramp, you might not always want to actually just have lightness being changed. So here, saturation is being changed and lightness is being changed, but you might actually want hue to be changed within the range of around 20 points in hue. So, what would look good? I know that this is reddish, so I don't really want that. Let me go there. So slightly, I guess, a bluer tone. And when I spread this, I don't think that changed too much because it's already quite bright. But yeah, the saturate, the color palette, maybe even a bit more, so we can actually see the color change. I mean, it's a subtle change, but I think it did change. Let me check. Yeah, so here's the old palette, and here's one that's hue shifted a little bit, slightly more analogous. Actually, no, wait. Yeah. So as you can see, this color looks a bit more. This is actually one that's hue is shifting as it's spread. This one is hue staying the same, and you can argue that this color, these colors are a bit nicer to the eyes because they're not just one shade. They're not sort of pure in one shade. Yeah, they're kind of mixed. Or at least that's something to think about. So analogous colors, let me really show you what analogous colors are. So you have your red, well, that's here on the hue, and here it's 90 degrees, I believe, divided by 90 divided by 4, so 63. So I want to add 63. Add 63. And also well, I can't go any lower than 0, so what instead I have to do is go 255 is basically -1, so I take away 63 from this, which is around about here, I guess. 63. No, it's actually 45. Yeah, so this is my center color. Any color within, like, yeah, that makes sense. Excuse me. Instead of 63, we want about 30. 30 and about. Around about here. So these colors are analogous. You can see they're different from each other, but they're not too different from each other, which is nice. So these colors, so any color within this range, so this is analogous, this is analogous, all these colors are analogous. Yeah. Yeah. This color is analogous, this color is analogous. Yeah. So now we have complementary colors. Complementary colors are 180 degrees away from each other. So, yeah, how's the best way to think about this? Maybe, is it? No, it's, yeah, so you want to choose a color, any color, say green, and this negating work. Yeah, you want to add about 126, 127, so negating. Yeah, that's around close to that. Negating button does it for you, but if you're not using graphics 2, you want to add 127 to this color. So let me take this color here, add 127, 1, 2, around about 230. So that's as complementary. Yeah, I always think of pink as minus green. So there's your complementary colors. Yeah. A triad is a set of colors that are equally spaced apart in the color wheel. So you pick a color. So you have colors that are 85 points up or down. 85 points up or down. So red is quite hot. It's actually quite easy. So triad 85. And this will have to be 85 minus 85. 170. Probably because I haven't changed I haven't copied the color. But yeah, so these are a triad. So yeah, I mean red, green, blue is one triad. Let's see if I hue shift everything a bit. These are all triads, I believe. I guess until, oh no, that does work around as well. It's quite cool. So these are all triad colors, right? So this is one set of triad. This is another set of triad. It's another set of triads. Things like that. Colors. I think this somewhat works for complementary colors as well. However, it does get a bit confusing when it's hue, saturation, light versus paint colors. Secondary colors are two primary colors added together. So think of it, when you're doing pixel art, you kind of have to think about it in your head. I haven't found a better way, to be honest. And so you have red, blue, combined together make purple in pigments. And purple, green, and orange are your three primary colors. Now, if you don't want to add exact amounts of the primary colors, you can add 2 parts of one primary color and 1 part of another. So you can have sort of reddish orange, things like that, bluish green. These are your intermediate colors. Warm colors are basically these kind of colors, so red, yellow, orange. They're usually quite warm. They're considered warm, so they bring attention to them. Cool colors are basically your shades of blue. kind of think of the sky as blue, so you don't really focus on the sky as much. Say something's moving to you, say like something's moving to you and it's slightly blue, you might not notice it as much as something moving to you that's quite yellow. So yeah, these are cool colors. I would personally say that also like darker colors are bring less attention to them, and kind of brighter yellows, they to me bring more attention to them. So consider them more warm. And that brings me on to the theorem. Values that are close together, cooler, or less detailed bring less attention to the piece, and values that are high in saturation, more detailed, more warm, they bring more attention to them. Right. So, thank you for watching. You're never going to fully understand color theory, and unfortunately color theory is something that isn't an exact science. I mean, I say unfortunately, but it's also something that makes it great, is that everyone has a unique take on color theory. These are kind of set standards that everyone can follow, but realistically it's a stylistic choice, and your visual appeal to the piece is more important than anything else. Yeah, thank you for watching. As always, please do leave a like, a comment. If I got anything wrong, please let me know. It's great to see my videos getting comments and stuff. This video took quite a long time to make, and if you're feeling especially generous, there are always donation links and things like that. But your attention is one of the most valuable things that you can give me, so thank you very much for that. I hope you have a very good day, and yeah, take care.